Okay, I'm here. Okay. How's everyone doing today? I might have lost track of time yapping. Um, Hopefully all are doing alright. I forgot to change this number. Oops. It's day 87. Yeah, I just typed that number. Day 87 of studying compilers every day until I land a compiler role. Good to see, good to see y'all early, Nyash and Skittles. I think I've like explained instruction selection once before, but it's like the process of taking our middle end language and mapping it onto, I guess, assembly. Assembly is like very formally made of instructions, so yeah. The big problem is that they don't map one-to-one, so we need to do a couple of tricks to, I guess, do that in an efficient manner, and that is the whole problem that I'm trying to solve here, pretty much. Yeah. So last time we learned a little bit more of the theory behind tree merging, so this time I think we can finally start trying to implement it in some efficient-ish manner. So yeah, it's gonna be a good time. There are people that are loud outside my door in one direction. There are people playing desynced music across the street in the other direction. It's gonna be a good time. This is how all good evenings go, I guess. Okay. I'm already in Tmux. Oh boy, what is happening? Oh, that's good, Niraj. I took a minute to explain instruction selection a second ago. Let me know if you want me to like try and give like an actual real explanation once again. I'm waiting for, okay, there we go. Alright, let's, I don't want Newbimon here. Did I change? We did scaffolding. Okay. Yeah, okay. So we want to merge. I want to go in here. I did all, or like I explained all this logic last time, sort of, so we kind of have to implement that now somehow. Yeah, so these are like our buffers, I guess. Rendering IR to assembly? Yeah, pretty much. The reason why this is so difficult and the reason why I'm making such a big deal out of it is because they don't map one-to-one onto each other. It's kind of like mapping at like M things to N, or M inputs to like N outputs. And they do not map one-to-one in any degree. You might have like some combination of N, for instance, per M. And then depending on the combination of M, you will get a different N. So it makes a really big mess. So we have to, I guess, get around that trick a little, get around that mess a little bit. Yeah, so that's like kind of the whole idea here. The idea is we want to, I guess, make the, basically write algorithms that decide the most efficient conversion. Yeah, pretty much. It's really slow to do it optimally, so we're gonna just go for a local minimum and call it a day, I think. Yeah, so the idea is we want the best output, and the best output, I guess, has instructions that cover multiple input instructions, or as many as possible. So the way we do that is we generate tiles that map to assembly instructions, or like combinations of assembly instructions, and those have like a they have like a weight assigned to them, and we want to, I guess, take sequences of the IR language and we can kind of like turn those into trees, and then we can cover those trees with tiles that represent instructions, pretty much. That's been like the whole thing I've been trying to explain. So yeah, the process for that, I guess I could go back to this MR to LAR thing. So first we want to generate like the base tree per instruction, because that is something we can kind of do one-to-one. A tree is just like it's not really assembly, it's not really the IR, it's kind of another IR, you could call it. But it's just like some sort of a memory representation of, I guess, the not really syntax, I guess just like the logic. So we can do that, and then we can merge those trees to make bigger trees, and then we can cover those trees with the assembly instructions that I mentioned before. I think I don't really have a good way to like diagram all of this because I haven't thought a lot about the assembly yet, so we'll see what ends up happening. Can you make a compiler without IR? You technically can, but it makes more of a mess to not use it. So, like an example of a simple compiler without an IR would just be like something that like expands macros. So like you just like read a line, and like if the line matches something, you can like expand it. But it makes, again, it's just like really difficult. It entangles a lot of logic. It's just a generally cleaner software design to use some sort of a memory representation. Because then that's just like, you can kind of better compartmentalize logic, and you're separating responsibilities into different sections of code. And that just makes everything a whole lot more maintainable. So, yeah. Okay, so we're gonna go back to the tree merging stuff. Let's go here. Okay, so we're iterating through this. So if it's not an assembly tree, we want to update the uses. So uses, and we're iterating backwards. Okay, so we can just push back, I think, right? So we want cur push back, and instead move dref iter, I think? Can we just do that? Super overwhelmed by assembly at the start of the semester, but starting to click? Yeah, it's just like, it is just like a very literal representation of what the program is doing. The hard part is less like, the hard part is just like putting the pieces together and just like the sheer amount of stuff you need to remember. Like MOVZ, like MOVZBQ. Like what does that even mean? The whole instructional programming thing was weird, but I still get it. Yeah, like it is just like, it's just like, what if we took all abstraction and we just threw it to the wind and we just told the computer literally what we want to do, which makes sense just like goals wise, but still it's like a little bit tough. Okay, we want to update uses, so uses at yeah, so tree. Oh wait, this is tough actually. Oh no. Okay, we might need unique pointers here. This might cause a problem. Want to teach computer organization? What does that even mean though? Or I guess as opposed to unstructured, I guess sure, maybe that kind of makes sense. That seems like rough though. Okay, this whole tree thing was a really big mistake, or at least without a unique pointer. Yeah, so let's replace tree, or in braces tree. Just, yeah, like this with instead unique footer to tree. Yeah, because then we have like ownership things we can share. And then in here we can change this from a ref to just a tree star. And that actually simplifies things a little bit, I think. Yeah, this looks fine. Don't even know, yeah, fair enough. So we want arrow get here now, right? Okay, we need to update some things real quick. So we need to do that real quick. That's fine. We need to update node real quick. Actually, no, this is all fine. Trees should be unique pointers though. The stuff inside them can be shared, I think is how I want to structure it. And then when we gen trees, we want to replace these real quick. What language is this? This is C++. But I'm making a bit of a mess out of it. This should be let's replace tree with, so we want this, and then inside stood unique footer to tree. We can, okay, so that find and replace does the thing, and now we need to fix a lot of things here. We can't in place back anymore. So we have to actually make the thing now. So let's actually do a little find replace here. In place back. Let's do a fighting one-eyed Kirby. Close brace that. Let's replace that with auto tree equals stood make unique. This takes tree, and then we can give it the group again, and then we can new line it 1 2 3 4 5 6 7 8 spaces, and then function trees push back. I'll push back stood move tree semicolon. Find replace, and it fixes a lot of things. This one is broken now, I fear. Oh wait, we need to. Here. So now this we need to replace with just tree. And then we can do this now. Yeah, so we need to fix a couple things, but for the most part, that was a pretty clean find replace, I think. I'm quite happy with that. Next one here. Let's get rid of this. This should be an arrow. Yeah, that looks good. One more here. Yeah, the whole YouTube handles thing is, I think it's a fair change, but it really sucks that like they didn't do this sooner, because then people would have like actual handles. It really sucks as like a small streamer, at least, having to kind of get used to using handles. Because it feels less human, because like everyone doesn't have like a name anymore, I guess. Everyone has a name, but like not really a name, you know? And it just feels really whack. I just don't really like it. It makes me sad. Okay, it looks like all of that's fixed at least. So does the build work? Okay, just watching while waiting for VMI to install? Ooh, fun stuff. Surely be able to toggle? Maybe. I think YouTube's leaning towards just making a fixed thing though. What is wrong here? Oh, get. And then we want to get root. Jesus Christ, that's messy. Oh wait, actually, what is get root? That's just a shared pointer. Can we just dot that? Wow. Wait, that's crazy. This line of code I just wrote. Let me send this to one of my friends. I'm sure they'd find it really funny. in under 45 menus. I think they're leaning towards not making it toggleable. The whole reason they switched was to like make it harder to impersonate people. So in that sense, it's kind of awkward. Yeah, that's a little unfortunate. Okay, so we can move this onto cur. That's fine. Yeah, like it's a very sensible change, but it just sucks they didn't do it sooner because it's really annoying to have to adjust to it at least. Yeah, it is what it is. I can only complain so much about it. Okay, so uses at SM tree. This is a node star, right? Yeah, this is a node. I want to push back. Oh wait, we need to. So all of the uses. So we want to each of the leaves. Yeah, it uses all of the leaves. Right? Wait, no. Which direction do we want to go? Oh, is used by. Okay, so we want to push back the tree from the leaves. Right, so for auto leaf in, or we can just do node in so you want iter get, then we want to get leaves. So for each leaf in here, oh no, it shouldn't be a set, huh? No, it should be a vector. When you're gonna daily drive a Linux distro? I sort of do in the sense that my laptop is running Arch. I'm just too lazy to install on my PC now. I also do play a little bit of Valorant, which makes things a little more complex. A node. So we want node ref. What laptop do you have? It's a modern ThinkPad, so we get all the. I get to look like I'm a ThinkPad user with with none of the benefit of it, I guess. But it is what it is. It's the newest Intel architecture, so it's like quite battery efficient. It lasts like, I think I have enough battery for like 6 hours of just like light, like thin client sort of work, which is really nice. Okay, so we want uses at. Do you want to push back? We're iterating through this in reverse order. Oh, this is gonna need to. Alright, we're gonna need to make this a list actually, because we want to be able to push front without being really slow. Gonna do this. Why doesn't this work? Can we just do this and then node ref? What type is this? What are leaves? Are these just node star? Oh, these are shared pointers. Oh, wait. Node get? Yeah, okay, so we can do this. So uses at node.get, we want to push front. We want to push front. Iter get. Right? should be tree star. So git, and then yeah, that's just a tree star. That should be, yeah, okay. I need to arrow that. Okay. There is a chance the leaves are not unique, and we're not really going to be searching through it like that, I think, or at least a linear search through that I don't think is that bad. We might need to use a multi-set. We might need to use a multi-set. Right? Do we need to? We should definitely use a vector, I think, or at least we shouldn't use a set in this, at least, I think. Yeah, let's redefine this real quick. A vector might make sense. We might just use a multi-set. M2 MacBook Air, but also desktop PC. Yeah, exactly. It's kind of like that situation. 2019 Strix laptop. Yeah, you kind of just have to like anchor it to a wall. That's the gaming laptop experience. Yeah, we might have to just use a vector. Which really sucks. Is there a better structure for this? I feel like... A vector bad in permanence compared to a list? A vector is definitely... Or yes, it is objectively worse here because I'm pushing front. That's the key thing, because if it was pushed back, then I would easily just use a vector. But we're not really going to be iterating through it, so the benefits of vector aren't really that substantial. We're kind of just using it as like a queue, or we're kind of using it just as a stack pretty much. I guess like a DQ, I guess, a deck. But like a deck just implements with a list anyway, so it's like, it doesn't really matter. The problem with push front with a vector is that it is O of n, whereas push front for a list is constant time. And it's like actually a really big problem because you have to like, because a vector is just an array with a wrapper around an array with the usual dynamic array stuff. So you would have to literally like copy every element over one and then like put in the front, and that's just like really annoying. And deck, yeah, I've heard deck. I think DQ makes sense to me because it's like double-ended Q. DQ. Let's actually look this up. Deck. Let's see. Deck, DQ. Yeah, both work, I guess. DQ. There's some pretty funny ones here. Yeah, I have historically called it deck, at least. First time seeing this, welcome. What phase are you working on? I'm working in the back end right now. I'm trying to do instruction selection, but it's kind of hard, so I'm kind of just going through it, I guess. This is vector. Yeah, so we can do that. I need to update in here. How many inserts do we have? We just have 5. We can just find and replace this. Yeah, okay, cool. That was pretty quick. Okay, so we can do this now. This is important because we might have duplicates. I'm thinking about using a multi-set, actually. That might be worth. Controller is a game changer? Yeah, it's so nice if there's like 20 things. Or if you're just like trying to rerun a really long command. The problem is like it does pop, so... Or like it pops off of your bash history, I think. So if you like mess it up, then like it's super doomed at least. Okay, so this makes sense. So we update the uses from the back. So it does that, and then we add this to the work list, I guess. Or we call it cur, but yeah. That's good, yeah. So in compilers class, we don't cover instruction selection. Yeah, I think they usually cover it towards the very end. I think the way a lot of compiler classes are structured is like, you spend like 6 weeks on parsing, which is like really annoying because that's the one part that I think just never changes. Like I don't think we've made a lot of progress on parsing, at least for a hot second. And then like you blow off the middle end, and it's like, yeah, like constant folding exists, and like you talk about like automata, and it's like, who cares? But like you learn like 2 optimizations, and that's cool. And then like you spend like 1 week just like hand wavily covering the back end, and then like in the last class, like you probably just get told like, oh, by the way, this thing called Bison exists, and then you wonder what the first 6 weeks were for. But yeah, there's a lot that goes into compilers beyond just parsing, and it makes me really sad that a lot of classes spend a lot of time on parsing, at least. That's just my take though. Do you think compiler rules are safe from AI? I think to some degree. I don't think they're very... I guess like AI is not really great at code analysis. It's alright for like generating code, but like I think AI's ability is currently that of just like an intern, pretty much. For the most part, at least. Like, if you have like, I think like having an AI help you programming is like, it's like having an intern that like claims to know TypeScript, you know? Like, it might get some things correct. It might know a couple tricks that you don't. It also will frequently get things wrong, and you kind of just have to like figure out the best times to use it. And I think in terms of like system stuff, it generally tends to struggle, but that just has to do with the training data, at least. Okay. So is this splice correct? This looks correct. This is all clean up. Trees. Is this in the right place? No, this is fine. This is correct. So, yeah, because this is a segment that we want to merge on, I think. Yeah, okay, so we want to merge like this. Yeah, so that's fine. Okay, and then we want to try merging one more time here. We should definitely make another helper to separate out the merge stuff, I think. Yeah, okay, so let's take merge trees, let's add like void. Or maybe we should just make this consume and then we should do like merge. Like process trees? Yeah, that actually makes sense to me. I kind of, I don't know. What's wrong here? Oh, right, this is still broken. We're reaching your goal. So I have a compiler internship for this upcoming summer, but I'm not counting that towards the goal because A, I kind of enjoy streaming, and B, it's not really a full-time position. So, yeah. For the purposes of the stream, I don't have a role yet. But in terms of career progression, I think I have like a stepping stone at least, and it's definitely very large. Let's do this real quick. Actually, let's undo that. That's thank you. AI's not taking over in compiler cybersecurity, a lot of things. Yeah. I think the interesting thing is like cybersecurity is like an interesting case because I feel like we're like it can like help in some places, but like it might it might make a bit of a mess. AI like makes cybersecurity more important, but then like we're also using AI in cybersecurity, so it's just like it's just a slap off, and it's like kind of funny to think about. Just wanted to wish you luck. I'll keep seeing out America Recommended. Thank you. I appreciate the support. Lots. Feel like an imposter, can't code without AI. I definitely felt like that a lot before this year. I kind of just like co-piloted my way through like a couple classes, and like I very much regret it. Like if you asked me like how to implement a WebSocket, maybe like 2 years ago I would have been able to. Now I just cannot. If I was like fresh out of my networking class, I would be able to, but I basically did not learn a thing from that, and I regret it a lot. The biggest thing for like, I guess, being able to code without AI is just to take the plunge, and you kind of just have to go with it. Once you like figure out the syntax, it'll be a lot more fluid. At least I think that's the big thing. That or just also like AI kind of vomits out really messy code. Because it's like the most popular wrong answer. So while you're at it, you'll also like learn how to write cleaner code, and it feels really nice, at least once you've made the leap. Okay, so we want do merge, I think is what we want to call this. We want to give it a list of tree. We can just yank around this actually, and we can paste over that. Yeah, so we can give it a list. We can call this a... What did the slides I looked at last time call it? L3... Okay, let's look through this. Context. Context. Yeah, we'll just reuse that terminology from the slides. Last year I was an Adreno developer and felt bored, so I moved to cybersecurity. Yeah, that's fair. It seems very alive. I trust that if you're doing the work to build that experience, I think you will make it. I believe in you. We will make it. We will all make it. Okay, so this we want to... Oh, this should return bool. Yeah, because we want to set change to that. Oh, wait, another really funny thing we could do is just while do merge. Wait, I kind of want to do that now. That's really funny. Yeah, we could do that actually. Yeah, we can do try merge. Let's call it that. Nice work. How can I reach you? In what context? If you mean like contacting me, Discord's probably the best place. If you mean like learning the skills, I think it's just a lot of hours at the end of the day. If you don't have a lot of compilers knowledge or like programming languages knowledge, I think or like as in like PLT, not like what is C. I think a good book to start with is called Crafting Interpreters. It's free and it walks you through like making an interpreter and then a basic compiler. I've heard really good things about it. I haven't worked through it myself, but I plan to at some point because it seems pretty cool. Contact? Yeah. The best place is just on Discord, in the server. I've been trying to respond to like, avoid, I guess, my DMs a lot, but like just in the Discord server is good. Also like LinkedIn is probably good. Telegram, WhatsApp, not really. I don't really have much of a presence on either. Okay, let's try this real quick. Try merge. This is really funny actually. We can try merge cur. And then we can just make this an empty loop. Where can you reach you? Discord or LinkedIn are the two places. You could also email me, I guess, but like I would rather not. Okay. So this is probably some of the funniest code I've written. Is this valid code? Oh, that's so funny. Wait, this is crazy work. I'm putting this in the Discord. I think this is quite funny. This goes into stream media. Let me clean up my pings real quick. Okay. Anyways, I'm just gonna leave this code as is, I think. Is there a cleaner way to do this? This is quite cursed. There has to be a better way. Have a Discord? Yeah, my Discord's in the description. I don't want to be that gay, but like, I can't really tell if you're like listening to what I'm saying. Okay. So I guess we could just leave this as is. Or actually, maybe we should put this inside of here, inside the try merge. Okay, let's try this. Let's go to cur ref maybe. Okay, we can just do that, I think. Yeah, this should be void, I think. Yeah, so we can do that, and then I think we want to splice first. I think this is more clean at least. Okay, so we can do that, and then we should do the fixed point thing inside. Yes, let's try this out. We want to try merge, cur, and then we want to splice one more time. Alright, and then I think that's all we need, actually. Okay, and now we want to actually implement try merge, which does not look like a lot of fun. Tree merger. Yeah, okay. So now we can throw the fixed point algorithm in here. The trees should be in, the context should be in backwards order, I believe. Little note for myself. Okay. Let's put this above, actually. Do this. We can also do like not changed. Actually, set it to false. Oh, wait, yeah, this is correct. Yeah, so we want this to be true. So we want change to be false here. Yeah, okay. So now we want to do the whole merge mess. Okay, let's take all of this out. Let's move it down into here. Just so I can like read it better. Okay. Whew, okay. So all of these conditions need to be true, or at least all three of these need to be true. And each of these are a case of that, at least, or I guess an arm of that. So in a sense, all of these need to be true. What's good? Siko, I'm not sure if I pronounced your name correctly, but yeah. Welcome to the stream. Okay, so we want to work through these somehow. Oh, it just occurred to me, I should also probably... I definitely need these two as well in here. Maybe I should just give this like a lambda? Yeah, let's throw this into a lambda actually. Yeah, let's give it a lambda. Yes, we can do this. Yeah, so let's get rid of the try merge thing. Yeah, we don't need that anymore. We should definitely keep this though. Let's throw that inside the lambda. Yeah, okay. That works now, I think, surely. Or... Okay, that works. I hope. We should pass everything by ref, I believe. Oh, all this stuff needs to be above. Damn it. Okay. It's like this. And then... So we want to try merging cur using the knowledge from uses. And then we don't push on trees, we just push on cur. Yeah, like that. Okay. Alright, that seems a little bit less awful. So now we have to actually implement this, which does actually seem awful. Yeah, okay. So... how do we even iterate through this? I guess we could just take a tree and then... We could look at its uses. Alright, we could take a tree and we could iterate through its leaves, actually, I think. Yeah, okay, I like that idea. So we got auto tree in cur. Okay, so we want... so for each tree in there, and we want to loop through its... yeah, so auto A equals, or tree A, or, yeah. I'll rename these properly. Actually, maybe I just make this A, or tree A. Tree A is fine. We want to get root. Or no, we can just keep it like this, right? Damn, people be loud outside. Anyway. Auto leaf in tree. We want to get leaves. So each of these will be a. This is a. Why is this struggling? Oh, this is fine. So this is a node shared pointer, and this is a tree pointer. Yeah, so we want to iterate through it like this, I believe, per tree. Yeah, so you can get rid of that layer of nesting, I think. And this is where it gets messy. Actually, I kind of want to keep that. I think that will make things look less awful. Oh boy, okay. Huh. What do we even do here? Okay. So we want to check all of these conditions. So we want to skip if it's not dead after. So if it is the last use, then it is dead after this point. So if use is at leaf get and then we want end. If that is not tree get, then we want to continue. So we want to skip this. We want to skip this cycle. Not end, back. There we go. Yeah, so if it's... Yeah, so that would make sense. I think that also covers the only use thing. Okay, so we can De Morgan's law this actually into an and, I think. Or we want... So we want to inside, so if not dead after and... So we want to skip if it's not dead after and multiple uses. What does it mean to be dead? It just means that the variable is not used after this point in the program. So let me just like draw an example here. What's good on unknown user? Sorry I didn't respond earlier. Okay, so we have like, let's say we have a program which is like A equals 10, then we have like B equals A, C equals like 5, and then like D equals A. And then like return. So if we look at the variable B, or I guess like we can draw like which variables are alive at each point in the program. So at this point, the set of alive variables is just A because we use A after it and it's in this instruction. At this point, A and B are alive. But after this point, B never gets used again. So from here, we add C to the list, but we use A later. So in this, B is no longer alive. So it's just A and then C at this point. And at this point, we don't use C anymore. So we just have D and A that are alive here. And then return, all of them are dead. Yeah. So looking at this, if we were checking whether B is dead after this, we look at these further lists. There's no B there, so B is dead after this point. Whereas A, if we were to check, A definitely exists further on. So, yeah. A variable, I guess, is alive when there are still uses of it, and dead when there are no more uses. Yeah. So this is the case we want. Okay, so we want that. We can just uses at leaf get. This should be by ref though. Okay, so we can do that, and then see if this is not that. So if uses stack size not equals 1 and that, then we can skip. Or maybe this is still not correct code. Is there even an instance where we can use a variable that's declared later? I guess not really, huh? Yeah, this might be a pointless check actually. Maybe the slides have an example that I'm missing. Let me rearrange things. Okay. Maybe there's something here. I guess that's not really possible, huh? So that's kind of a trivial check. Yeah, I think we could just get rid of that check, but we'll find out the hard way if we can't. Yeah, let's give this a try. I did this because it makes the syntax a little cleaner. Slides are brutal. Yeah, it was better when there was like an actual lecture, but such is life, I guess. I could watch back the lectures, but I feel like my school would get quite mad at me if I streamed them. So, yeah. Okay, so we satisfied. Yeah, we satisfied this condition. We need to check if there's no. Oh yeah, this is intrinsically satisfied because we're checking this sort of range. Right? Oh wait, no, we don't check this yet. Can we maybe just like check cur even? Yeah, maybe we should check that it is if there's no assembly node between. Or actually, do we even need that? I don't think we need that. Right? Is there even an instance where that causes a problem? Let's just like write this out more formally. So we want to skip if between, and then skip if instructions depend on T2. Oh wait, we could actually, I guess we need to like check all the instructions anyway. So we could just keep looping backwards until we find it in the range, and then if it's not there, then we can safely say it's it would have to have a ASM node in between. That makes sense now. Yeah, so we have like, just to elaborate, we have T2 and then some sequence of instructions and then T1. So we want to start from T1, which is, I guess, tree. And then leaf is T2. So we want to just keep iterating backwards through the list until we find it. And if all the conditions are true at that point, then we can safely merge. If one of the conditions fails in between that range, then we can then it's not a safe merge, so we don't merge. And then if we just don't find it at all, that means we're either out of nodes completely, or the node that would be there is an assembly node. So there would have to be an assembly node between these two instructions. So that is how I will implement this. Yeah, so we can do another loop inside here, which is pretty funny. Or we could do it in like a one pass way with like another data structure kind of storing it, but that seems awful, and I really don't want to do that. It looks like we're gonna have to iterate through it anyways, so what's really the harm, I guess? I can optimize it later, I guess. So, Oh, maybe that also means we might need this to be an iterator, actually. Yeah, we're gonna need an iterator, actually. Yeah, and then we can just copy the iterator and then modify it. Yeah, okay, let's do that. Okay. So we want cur begin. Yeah, so we can iterate like this. Tree equals iter get, or can we just deref iter? Oh Jesus, what happened? Oh, I forgot to put a brace. Whoops. Okay. Okay, so that looks like I fixed that. So this is the tree. Maybe we could just get this even. Yeah, so we can get that putter. I don't think we're gonna be copying this tree at least, so that should be safe. That's also nice because we can change this. We can remove this get as well. Yeah, so we can do this as well. Leaf can't really be an iter here and make sense. So this makes sense. Okay. So here we want to iterate from, we want to start from the current one, or we go back one. So we want tree to leaf inclusive. Okay, so we want check iter or inner iter. This is just a copy, right? This looks like it's a copy. inner. Yeah, so we want while minus inner iter. So we want a decrement first. So if that is we want it to because we want to iterate one more time once we found it as well, I think. Yeah, because the other condition matters as well. So no uses, no defs, and no memory instruction if mem access. Okay. So we could just like do this and then get, and this is a let's just put a brace on here real quick. What is wrong here? Oh, this needs to be an arrow. So this is the tree, and then we want to get root. And then we want to get. Right? And then this needs to not equal. You want it to not equal the leaf value. What is leaf? Leaf is a shared putter. Shared putters. Yeah, so we want to compare the. We can just compare the pointers. Interesting. Okay, well, yeah. Are you in grad school or is this an undergrad project? I'm in grad school. This is just a completely a personal project. I guess I'm both in undergrad and grad right now. So it's a little bit complicated, I guess. Yeah, so we can do that. This is really ugly to look at. So that's a node star. This is a node star. Perfect. So that is the condition. And then if v is a variable, so that would be a register, and there should be no uses in the range. If this is a memory access, then I guess it'll always be a variable, huh? And then if it's a memory access, it would be, we'd still have a register in between to store the value. So then, or we need like contains memory access or something like that. Right? Yeah, so we want no use in the range, so this needs to not be a use. Okay, so we want to okay, so if so if there is a if uses yeah, so if it uses the variable, or if it uses what, leaf, I think, Yeah, if it uses leaf, then cannot merge. So if cur is a leaf of leaf, then cannot merge. Oh man, this is really troll. I should have just stuck tree putters, I think. If there's a way to make that a thing. Yeah, because we need a leaf of a leaf. This is really annoying. Yeah, we might need to do a little bit of data structure rewrite as well then. Yeah, we might need like a wrapper or something around it. A better way to do this. Okay, and then if mem access so if this is a mem instruction, then give up if and leaf it has mem instruction cannot merge. Okay, this is really tough to write out. I'm not having a great time. Yeah. So we might have to do a little bit of rewriting. Yeah, so we need a new like has memory instruction field, I think, and that will be easy to update. We can just end it, or we can just OR it, and that will just like, I guess, poison upwards. Yeah, and then yeah, so we need trees in the root now, which is kind of annoying. We just need a better way to, I guess, implement the skip list if that's at all possible. We might just have to have like a global skip manager. Yeah, that might have to be the play. So then we can also just make like a tree collection object even. That might be smart. Yeah, and then we can like do insert trees or something like that. Okay, I'm gonna try that out actually. I quite like that. This feels like something that I should really just put in another stream, but it's fine. I think this means we can get rid of this tree structure though. We can do tree list, I think. Yeah, we can do tree list. Yeah, and that also gets rid of like the annoying vector stuff as well, I think. It gives another layer of abstraction. Tree collection? What do we want to call this? Anyone got any interesting name ideas here that stays readable? It's just a collection of trees. But they're also like sequentially ordered. So I guess we could do like tree sequence or something like that. Tree list. Yeah, actually this makes sense. Forest would be really funny actually. I kind of want to do that. But we're just skipping straight from node to forest and it's a little bit funny, I guess. That's really tempting actually, fuck. Okay, we're gonna do forest for now, I like that. Okay. Yeah, so this is fine. I don't think we need a constructor anymore. We definitely need to restructure this stuff though. So we want a list of so a list of std shared putter or unique putter actually. Shared pointer? Because these are nodes, so we'd want a shared pointer here. A shared pointer of node. So this is trees, I guess. Nice. And then we want a map. We want to map to node star, I think. Or we want to map to the... Or actually, we could just get it with putters, right? No, we need the shared pointers. Yeah, so we want a std unordered map. From node star to a, we'll just do vector for now. Std shared putter of node again. This is really unwieldy. I forgot a, yeah, okay. Jeez, what a data structure. Okay, so we need to rename this stuff. We went to insert tree. So this should be insert tree. This should take a shared putter to node tree. And then what else did we need? Or there should be leaf tracker or leaves tracker. And then we want something similar here. The node star to this should be, I think, wool, and this should be has mem instruction, or it should just, maybe this is just like leaves and then has memory instruction. Yeah, okay, I like this. So we want that, and then oh boy. I guess we can kind of just like, we can add to this as we need things, which sounds awful, but it's really not that bad, I think. So we can get rid of tree. Oh boy. So we need insert tree. We got forest, holy crap. Okay, so we want trees, we want to push. Maybe this should just be like a collection, even. We could just... We can just get trees, we can... Yeah, and then we can just like access the other two. I feel like this should always insert front. Yeah, actually this works. And then we can make like a subtree out of it, I think. Or you can make a list of... Yeah. Oh wait, there's some really funny class naming ideas I could do. Okay, let's push front. I like that. And then, or maybe we could just like, we could worry about the implementation later. Let's just do that for now. We need to update gen trees because, well, we don't really have trees anymore. We've committed deforestation. So we need to update this real quick. So this should be forest. That's really funny. Yeah, so this is forest, function trees, and then we have a list of forest. That's too good. Okay. Maybe I want a unique footer actually, because if we're like returning this. Actually no, this is fine. We can just move it. Yeah, so we have list of forest. Get result. Yeah, okay. This is all good now. Okay. So now we have to fix a lot of things. So we can do this. Forest. Huge. Instead of this now, we have the node. So then we have this, we want to, instead of push back, we want to, yeah, do you want to push back? I guess we want this to be sequential. Yeah, we want this to be forward ordered, I think. Yeah. Right? Yeah, and then we can like substring and then reverse. And that shouldn't be that bad, honestly. Feels like we have to do a reverse anyways, so. So I guess this should just be add tree. So that's a unique footer to a node. Why is this a unique footer? Oh, it's an ASM node, I see, that's why. So why is that a unique footer again? Wait, this didn't make sense to me. Yeah, a tree, what did a tree used to take? If we undo this. Wait, this was just wrong actually. Okay, well I guess that's really funny to find out. What's good, Bisfoot? Good to see ya. Okay, so we want to make shared anyways, just for interface. And this should be assembly. Yeah, so we want to add tree is, or sorry, insert tree actually. What happens if this was make unique? What type is this then? It's a unique footer. Why does this work? Anyway, this seems correct. So we'll do that. It'll just be a shared pointer that, well, doesn't get shared, but that's fine. Okay, so we can do that. End function, we want yeah, so then so we'd move it back, so I think this is fine, right? Okay, so how do we even clean this up? Okay, so we can just reset it, I think. How do we even reset this? Oh, that works actually. That's nice. Okay, next one down here. I think we can just copy this stuff, to be honest. Okay, next one. This one is interesting. I'm gonna save that for later. This is another assembly one. We can paste over that. That one's interesting. Paste over that one. Actually, no. That wouldn't work. That one is interesting. This one is not interesting, so we can do this again. This is another assembly one. We can paste over that. This is another assembly one. We can paste over that. This one is another assembly one. We can paste over that. Okay. So we have a couple more now. These are all the interesting ones. So just so I can have a reference, we can do that. Why was I make uniquing the trees? Oh, yeah, because the trees need to be unique. The stuff inside didn't need to. Yeah, so this was like make shared. So then yeah, okay. So here's what we're gonna do. We're gonna make the vector and we're gonna pass that in as like, or maybe we could like, yeah, we could give it like stood vector of shared putter node leaves, and then we can give it pool has memory instruction. Yeah, okay, that seems a little bit more workable. We need to change a lot more things now. Yeah, this is assembly, so I don't think either of these really matter. I think we can just we could also just make like a generic one that, well, is uninteresting. Right, can we just do this? Maybe we could do like insert assembly. Yeah, we could do that actually. I quite like that. That seems a little more clean. Okay, this is a mess. So we can skip this now. Do you go to school? Yes, I'm currently in university. So we want function, trees, we wanna insert tree. This takes in reg, or instead move reg. So you can avoid making a copy because that seems cleaner. We want to give it left and right. And then this should be, oh, we need to figure out the resolves there. I think these are atomic, so we can do false. Yeah, this should be valid. What do you study in your? I'm in my 4th year. I'm studying computer science. Yeah, okay. We can get rid of these actually. That's really nice. Yeah, okay. That actually cleaned up very well. Yeah. So we do that. This, we need to change this to ASM. Good luck with your journey. Thank you. Appreciate the support. Okay, so this one we need to be more interesting with, because this is an LK. So I don't think this should cause any problems, but what if it does, you know? Is 8 even the correct size here? I guess that's the size of a... Is that the size of a register? Or memory address? I guess it should be, yeah. This should be good. I think 8 seemed correct. Or maybe it's 16. I don't know. Eight bytes. Okay, yeah. So we did it correctly. Okay. So what did I change? Okay, cool. So we want function trees. We want to insert a set or tree. So this takes in the move reg, and then we have nothing, and then does this contain a memory operation? I don't think it should. It allocates, but I don't think that causes any issues, at least. This shouldn't cause issues. Or maybe it does. Maybe it does invalidate pointers, right? No, this should be fine, I think. We'll find out the hard way if it's not fine. Yeah, we'll find counterexamples. Okay, so next one, this is another one of the interesting ones. So function trees, insert tree. This takes in the move reg. I'm gonna give it putter or leaf, if I can type properly. And then this is a load, so this is true. Let's get rid of this. Okay, we can kind of copy some of this, I think. This is store. This has putter leaf and source leaf. And then this is definitely true as well. Or actually, no, this should be fine, I think. Right? Or wait, no. This is a right, so this definitely could cause an issue, I think. So that's a true. I think this is the only instance where we run into issues with aliasing. Yeah, so load should be safe, I think. And this makes sense. And we can get rid of this. It should be ASM. ASM. ASM again. Last one. ASM. Okay. I think everything's fixed now. So now we need to re-implement stuff for Forest. Forest is a really funny name. I'm gonna keep it for a bit. I might rename it eventually to like Tree List or something like that. Tree List seems reasonable enough, so I might do that. Or like Tree Manager or something like that. Okay, so we want to go here. We want to implement things now. Okay, so insert ASM should be pretty straightforward. So we want just trees. We want to push back tree, or instead move tree. We can do that. Here we want to set these first. So leaves, or leaves at tree get. Oh, this is ambiguous. That's really annoying. Yeah, okay. So we're gonna need to rename this maybe, I fear. But that's fine. We can do like tree leaves, and then we can do like tree has memory instruction. So we can do that. So for each leaf, we want tree leaves at tree get. So we want to, that's a list. So we should just, oh wait, we can just move this, I think. Right? Can we just do that? Oh, nice. Wait, we can just do that once then. Do you start with a transpiler or do you jump straight to compiler? This project I went straight in. Learning wise, I wrote a bunch of interpreters before for a class, and I wrote one big compiler for another class as well. I think interpreters are probably a good place to start, and then from there, it makes sense to, I guess, work on a compiler. This should be has memory instruction. Okay. This seems like a fair enough implementation. Ooh. Transpire to bootstrap self-hosted compilation. Nice. That seems fun. We can pass in this as ref actually. Yeah, okay. So then just to check everything is fine. Things might not be fine. What type is the initializer list? Is this an L value? Or, sorry, an R value? Okay, we're gonna do some really cursed stuff real quick. So that's broken, so what we're gonna do is we're gonna make this a R value, I think. Yeah. And then we're gonna go here. Let's make this an R value. And then, huzzah, it fixes everything. Okay. Crazy work. Yeah, okay. That seems reasonable enough. Huh, interesting. Oh, interesting. Okay, so we can actually just skip that semantics altogether. The more you know. So we can undo that, we can undo that, and this is still fine. Okay. So that implementation is updated. Now we need to mess around here now. This should be forest, if I can spell. Forest. This is by ref, yeah. So you can do that now. Yeah, this all looks way cleaner, huh? How about that? Okay, this makes sense. Then actually, instead of a forest here, we could just make this a straight up list actually. We can undo that. Because after this point, we don't really need the abstraction. We can kind of just tile, I think. Yeah, so this should be a forest still. But in this one, we should change. Unique footer of tree should turn into shared footer of node, I think. Is that what's the underlying thing in forest? List of shared, yeah, okay, perfect. Okay, so I have some really silly ideas for how we should do this, but all of this starts with rewriting some things here. Yeah, so we want to fix that real quick. That changes a little bit of stuff. Yeah, that's fine. This needs to forest. You still need to keep track of uses. But this just takes node star now. That will be convenient. Curd, this makes sense. I think we should keep all of this, but we should do like a pop tree or something like that. Yeah, we should do like a pop tree, maybe. Yeah, so the forest will be forward, I believe, right? It's in forwards order, so we want to like, yeah, we want to pop back, I guess. Or we could just do pop, I guess. Yeah, so we can just define this real quick. Yeah, I guess we could just call it pop, I guess. Shared putter of node pop, I guess. Yeah, let's do that. So we can't really do an iterator anymore. We need to like do more crisp things at least. So we also want bool empty, I think. Yeah, okay. Yeah, so we want, what is it? Trees, I think? So while it's not empty, yeah, so then we don't care about iter anymore. So we want trees pop, I think. Yeah, so we do that. Luckily, we can also skip a lot of this stuff as well. So we can just do tree get, and if it's not an assembly tree, then we want get leaves at least. And so we want a vector of stood shared putter yeah, so we need that. This should probably be a L value. Alright, that's broken. Made a transpiler but never a compiler. Compiler after current project, which is OS. Ooh, fun stuff. That seems like a very large project. It seems really fun as well. Terminal emulator. I'm using Westterm because apparently out of the big mainstream terminal emulators, it has the best support for WSL. Yeah, so we want get leaves of node star tree, I think. Yeah, so we want that. With that, then we want for each node we want to delete that, make that. We want to get leaves, so we want trees, get leaves of node, I think. What time zone are you in? I am in Central Time. So it's like 10 o'clock for me. Or wait, not node. We want tree. What's wrong here? Oh. This should be a ref, I think. Yeah, so this doesn't exist anymore. This is still fine, I think. This should just be tree, I think. Oh, we wanna get here. Okay. Okay, there we go. So we can do that. Inside of this, we want instead move tree. Okay, so that's fixed. And now, otherwise, we want to like merge. What the hell is splice? Oh, splice. This is fine actually. We can kind of keep this the same, I think. Yeah. Yeah, and then if we merge something in, we don't really care about the previous leaves, I think. Alternatively, what we could do is we could make like a merge instruction in the forest, I think. And then we can give it 2 tree shared putters, I think. Right? Or no. No, because that wouldn't be in trees anymore. Yeah, that makes a mess actually. Yeah, actually we could just do that. We could make a merge function in forest, I think. That's awful. I guess we could just call this tree manager. Yeah, and then that also gives like tree utilities, I guess. Okay, so we need to rewrite a lot of this, unfortunately. I think this is still fine. We need to change this now. So what is tree? Oh boy, what is this? This is a node star. So this should be trees. Get leaves at tree. So we have that. Hopefully we can like not have to do this garbage thing. Yeah, we don't need that anymore. Get just gives us the node star, I think. Yes, that sucks a lot less. Yeah, so the rest of this, I think, cleans up nicely. So I'm gonna do this, and then so we can do this as like a skip thing. Okay, and then here we can actually we could even just I don't really care about denesting here. So if can merge, then merge trees. All right, let's write out some nice to-dos for myself. Also, I'm just gonna take a snip of this for myself because I'm gonna be deleting this, I think. Or actually, yeah, let's do that, and then I'm gonna throw this in my Discord. I'm just gonna put this in my own like test Discord. Yeah, okay. Alright. So this is fine. I'm gonna keep this here. So while that's not the same as that, and then we also need like a compare as well somehow. Actually, can we just like prefix decrement this? Or no, that wouldn't work. So we want to check if the previous iterator is not leaf, right? So that's so confusing. Wait, this is really annoying. I'll figure that out later. I think that's a tomorrow thing. Okay, let's clean this up. That. So we do that, and then yeah, so we can do that. Yeah, okay. I think that looks fine. Merge. Alright. Let's try rebuilding. Hopefully it all builds. Uh-oh, that's not ideal. Where is this living? MR to LR. Oh, I see. Duh. We need to fix this up real quick. Ooh, what the hell? So this should be merge trees again. This needs to be fixed. So this is just the footer now. So we can just skip this now, I think. And I think we're good. Actually, make dist queen. Or maybe I should just call it like very clean. I think that'd be funny. I've heard people use very clean before. Uh-oh. Oh yeah, I haven't implemented those. Maybe I should implement them real quick. Yeah, I have the time, fuck it. Okay. So then, what did I change? Oh boy. Let's figure this out real quick. So this one, we made the change. Okay, So I need to implement those real quick actually, though that's quite important. Alright, that belongs here. I forget. Oh, this is Arma. That's really funny. So we do that. Okay. Implement time. So pop should give us so we want trees back. So we do that, and then trees pop back, and then return res. What is this? What is back? It's a shared putter. Stack memory. What do you mean stack memory? So ref? Or wait, no, we need to stem move. There, right? Is that it? No? Can I just like copy this? Oh, that doesn't work. What do you mean this is stack memory though? What type is this? This is a shared putter. Oh, so can I just move this now? Why is this a problem? Oh, wait. Oh, but this doesn't, we can't do this, at least. Okay, we're gonna ask ChatGPT for a little bit of help here. Okay, well, sure. So yeah, our value is a little bit insane in hindsight. And we can just move this. Okay. Why did I try to make this an R value? Why do I keep doing this crazy stuff? Okay, nothing's upset, so that's good. Okay, next we want to do get trees. Get leaves at tree. That one's pretty simple. Turn trees empty. All right. Let's try this again. Huzzah. Okay, well, it's gotta build twice, but give it a second. Also, I'm blurry. Hello, blurry me. Oh, I'm not blurry anymore. Okay. Okay, test still passed. That's good. Okay. How do I even begin to commit this stuff? Scaffold. Tree merging more and replace tree with forest. Or tree lists with forest. Okay. I think that's a good place to call tonight. It's been like almost 2 hours. Yeah. Thank you all so much for showing up to today's stream. Especially if you're new here, make sure you like the stream if you enjoyed it and sub to my channel. It really helps out with the algorithm and gets my content out to more of you. I guess I'm just permanently blurry, so blurry me is doing the outro. While you're down there, make sure to join the Discord. It's the best place to stay in touch with me outside of stream hours and chat with the broader community. You can also get notifs for when I go live, which is way better than YouTube's. Yeah. And of course, connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. I'm gonna go get dinner now. I'm quite hungry. Take care, y'all. Take it easy and have a wonderful rest of your day wherever you are.